Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, an argument for a holistic approach to critical infrastructure security with our special guests, Dr. Anna Scott and Steve Orrin. Anna, Steve, welcome to the show.
Good to be here.
Thank you, Darren.
I know it's hard to know who to go first when I'm interviewing two people.
Just so we're not at the same time. So, yeah.
You guys have been on the show several times. Steve, I think you're my number one, interviewee. I think Anna, you're second. This is like your fifth time, I think.
It's been a lot, so it's a pleasure.
So, and the reason I asked both of you on today was I wanted to get a different perspective on critical infrastructure security. First off, from a former CISO and a security expert, that's you, Steve, if you don't know, and also from an industrial IoT expert like you, Anna, because you've been in the trenches in industry trying to work through these OT and critical infrastructure environments. So both of you on together, we should help figure out what's going on as far as critical infrastructure cybersecurity. So let's first get kicked off by with you, Anna, a little bit. Is there a real threat to critical infrastructure cybersecurity, or is that just a red herring or something we're just hearing on the news because there's nothing going on in the news cycles today?
No, it's a huge concern, right? And it's a huge threat. It does depend a lot on how the individual companies are dealing with their systems. Right. There's still a predominance of the way you protect really critical systems is you just don't let anything access them, through anything except being in the same room with them. So that's a great way if you can, control around insider threats because you have a very limited attack surface and you've got a great deal of control in that space. There's all sorts of reasons why that just does not work well in the modern world because that tends to prevent taking advantage of a lot of modern technology, especially when you get into what you can do with analytics and analytics across different data sets. So yes, you can continue in that pattern, but you do that at the expense of not being able to take advantage of those tools and bring that competitive advantage into your space. But as soon as you do that and you connect into the internet or you connect into broader systems, now you've got a whole different set of protections that you need. And these tend to be things that are not well understood, and especially where operational folks make the call, which is what happens in this space, then you have some real challenges just in understanding what are the real threats, what are the real tools to protect against them. And the question that you addressed with your paper, Darren, which is, can we really use IT tools in this space and use them to good advantage? And I love that idea because I think there's so much more that can be done and much more that can be leveraged to just deal with the specific problems that happen in the operational space.
So what I heard a little bit there, Anna, is the Purdue model that everyone's been using, this isolation, either firewalled off or completely air-gapped. That's a naive approach in today's modern things because I need the data out.
Yeah, and I hate to use naive because I think there's some really good reasons for it. And I having worked in situations where my life has depended upon the systems working, and not having them be tampered with and having malicious intent, I'm pretty comfortable with that. But I do think that there's a big cost that goes with that. And so it's really like getting a good handle on your risk profile. Like I'm going to cite Steve here because I love this so much, right? It's like if you try and figure out how to do zero trust, what you have to start with is what's your real risk profile and what really matters, right? Because if you take that type of approach, then that helps balance off what's really happening when you do this to connectivity and you bring these data sets together, right? And so I think you still have to do an assessment, which is, do those new capabilities bring you enough value to overweigh the risk of the vulnerability of those systems, especially when you know, one, you're going to be constantly trying to keep up with the hackers and all of the new software and everything else. And that is a pretty high request and pretty difficult to do in some cases, especially with organizations that don't already have that type of capability. And so really having a handle on that relative to what's the real benefit to your business, right?
So
So
Steve, she quoted you. You got to come in and step back. And also, I want you to address a little bit of. I call it naive, and thank you, Anna, for correcting me on it. But I still think there's a little bit of false security behind a isolated network.
Yeah.
So,
And
Steve,
so, Darren, I think, and Anna does hit it right. It's understanding the risk profile. I think one thing, and maybe naive is not the right term. I think the cat is out of the bag. Um, those OT systems, that critical infrastructure is connected. They're connected to IT systems. They're being managed in a distributed fashion. They are getting tapped into from the OT IT side. They're interconnected amongst themselves. So the notion of a truly isolated OT environment or a critical infrastructure environment is actually a notion that isn't true anymore in many cases. What's considered to be an air gap of the old, or where you physically had space, is now more a virtual or logical air gap. And we're seeing attacks that can jump that virtual or logical air gap. And in many cases, the what you thought was a logical or virtual air gap is not an air gap at all. And so their systems are much more connected than they've ever been. And so I wouldn't necessarily call it naive. I'd just say, like, in some cases, it's already happened. And so the question isn't, well, should I open up my network? Your OT systems are already open. It's now, how do I start to apply the right controls, and falling back on, well, I'm just going to continually isolate. And that's been a major approach, is a good one. It's a tool. It's not the only tool, and it's not the complete tool. It's one of the tools. So encrypting the network traffic or providing logical firewalls to separate networks and do network segmentation is absolutely a great tool in the arsenal, but it alone will not prevent the kind of threats that these OT and critical infrastructure systems are seeing. And so when you look at it from that perspective, it's okay, let's understand the risks of the OT systems, understand how they're different from the IT systems that many of these security products and technologies were originally designed for, and apply those security controls in an OT fashion. And I think that's one of the learnings, both from the paper that you published, as well as what organizations that are doing this right now are seeing, is leveraging IT security capabilities and controls in an OT way.
so I'm glad you said in an OT way, because a lot of times I've seen the IT professional, the CISO, come in with a hammer on the operational guys and say, you need to be secure, update all your patches, right? Everything needs to be updated. And Anna, is that doable?
well, depends on how old your equipment is, right?
Well, I mean, yeah, some of this
And
equipment's 50 years old.
yeah, and then there's a lot of diversity in it as well, right? And so many of those systems were designed so that maybe you update the firmware once every 10 years and you're going out there with a USB stick to do that, right? Because there's
Does that
no
scare you, Steve, when you hear that? 10 years? You haven't updated your security patches in 10 years?
I wish it was something that was novel, but we see this often in OT edge environments, even in systems that are supposed to be IT related but are driving those
Oh,
OT systems. And
OTs,
that's
yeah.
actually an interesting point. Is when you go look at an industrial, a manufacturing line, or you go look at a smart city, or any of these sort of operational technology, critical infrastructures, and you go look inside the cabinets, you go look, it looks a lot like an IT system. There's a rack of servers
Mhm.
in there now that are driving those technologies, monitoring them, doing the operations that once was very analog. And so the scary part is those IT systems do need to be patched regularly. They do have vulnerabilities. But as Anna
So,
pointed out, there's a reason why they don't get patched at the same cadence that standard IT
yeah,
does.
and why is that, Anna? Why?
So they really weren't designed, right? They weren't designed with this whole idea of you're connected all of the time and you need to be constantly updated. It's well, what is it? It's the difference between streaming on your music on your iPhone right, where you're connected all of the time and everything's completely up to date, and having an old iPod where you could load it up once and then run that sucker until it died, right, or until it just really needed attention. So, and I shouldn't have used died because that's not how you think about OT systems, but it's just kind of the idea. It is just a completely different world if you are living in a space where you're constantly connected, and so much of the legacy equipment, it was never designed with that in mind. It was hardened in a way that once you installed it, you could really keep it going for very, very long periods of time. And so you have this much longer life cycle, like 10 years is
So,
on the short side
And
for
plus,
some.
so
the applications that are being supported by those systems are very different from your IT. So if your email goes down for a couple hours, so
no
it
big
goes
Nobody
deal.
down,
cares.
life goes
Yeah.
on. But many of these critical infrastructure are driving, power, water treatment, life-saving devices inside hospitals. They're not meant to be taken down by a patch that that didn't do
Mhm.
its quality assurance to the same level. And the regular cadence of being able to do things and bring things offline and bring them back in, that's a modern IT concept. But these systems were meant to, like Anna said, run for 15 years nonstop. And that's not something that is easily deployed patches or to be able to do inspections and security tools that get in the way of the operational technology. And that's again why I talked about IT in an OT way.
So it sounds to me like there's a total mismatch in motivation and in results in the OT space, right? High availability. We're not talking 3 nines. We're talking 12 nines, right? I don't want a heart monitor or a heart machine to, oh, I need to reboot it. I need to reboot every 3 days. You don't want that. Or even your power grid, you really don't want down. So because the motivation is so different, can I really use the same techniques in IT and OT? Or or do I just go and I understand the isolate myself because I don't want any change. Things are working. Don't bother me. Right? Isn't that how it's done, Anna?
Probably way too often, right? And there's definitely risk associated with trying to fix your problems, right? The same way there's risks with just continuing to do nothing and keeping your fingers crossed. There's a lot of very clever people that still want to find ways to disrupt systems, even the legacy systems, right? And in some ways, many of the legacy systems are more vulnerable because they were designed before modern hacking was really happening, right? So there's just some real concerns there. But I do think that there's a real place for having the IT tools, right? Like there's a lot of tools that can say, I'm going to look at the network. I'm going to identify everything that's on the network. I'm going to identify what is the current level of firmware. And then if it's set up properly, it can say what should be the current version and where do you have gaps. And some of the tools are actually sophisticated enough where they can say what's your real risk associated with not having those updates in place. And when you get into that level of sophistication, that becomes uh, very, very viable, right? Because now you have a clear picture of what's going on, and then you have a way to actually prioritize that risk. Granted, I don't know that you ever want to trust another company to do that. You probably want to be at least understand very clearly how the software made the decisions about where your risk really lies. Because there's no way a software company knows what each of your individual components are really controlling and how critical those can be. So you got to stay very involved, right? But if you have that type of assessment, at least you can start out and do that. And my understanding is that's pretty common on IT systems, right? There are tools that can do that, and there's lots of tools that can do that. So at least you're not just having this big black box and a bunch of question marks. You can say, let's start doing that assessment. And if those types of tools can find things on your network, that means somebody who's coming into that environment can also find things, right? So you really do want to understand what's discoverable and what is its current status, and then determine where you focus.
So that brings up one of the best practices that we know about in IT cybersecurity, which is risk assessment. And Steve, can you talk a little bit about risk assessment? Because I know if we ran a vulnerability scan, there'd be tens of thousands, hundreds of thousands in any company. You can't do them all. So this is where the risk assessment comes in. So can you explain how I can leverage the IT risk assessment best practice in the OT space as well?
Absolutely. And so it really starts with what Anna was talking about. You can't secure what you don't know. And so starting with the asset inventory, the discovery, to understand what your assets are, understand what's running inside the box, what firmware, what operating systems, what versions. You need to create that asset inventory to be able to then do the next phase. And before you even get to your security considerations, the next piece of this, and this is actually defined as part of the NIST cybersecurity framework, is once you know what your environment is, understanding what they're doing. What is the purpose of those systems? And this is important. When you do your risk calculation, you need to know what are your mission critical, what are the necessary support systems to keep those mission critical systems operational, so that you can create that risk profile and understand the prioritization of applying the security. So before you ever get to your first encryption key or firewall, it's knowing what you have in great detail, understanding what those systems and processes and technologies do for your business, for your mission systems.
Mm-hmm.
And then from there, you can start to apply a risk calculus. And that risk calculus takes from published vulnerabilities, so CVE databases. There's new standards and formats around software bill of materials and vulnerability inter-exchange called VEX to be able to give you information about what's the vulnerable state of the components. There's a lot of great information out there already in the MITRE frameworks to let you do the assessment of what you found. So no, this version of Linux has got this level of vulnerability, or this particular product over here has these CVEs that haven't been patched in the version I have. So you get that information. Now you have, what's critical in your organization, and what the known vulnerability. The other side of the risk assessment, besides the known vulnerabilities, is understanding, and this is where things like pen tests, scanners, and other kinds of tools give you an idea of what your overall threat landscape is. Those come together into understanding your risk profile. So I understand what my current assets are, with the known risk, with the potential risk, and then what these things are usually important for helps guide the prioritization of, okay, now I need to start applying security tools. And it's only at this last phase that you start applying process, technology, and procedures to do the compensating controls to reduce or mitigate the risks that you've identified. And that's your standard IT flow that I've been describing can be absolutely applied to the OT systems, understanding that what you actually implement, the process, the procedures, have to be done in that OT way. So it's not going to be, well, I'm just going to push a button and patch everything, or I can just put an encryption system onto, or an antivirus product onto that PLC device. You have to be able to apply the right kind of controls, but it's only at that last phase of the process of assessing the risk environment, your risk posture, and then the prioritization that your assets tell you about, that then you can start to make the decisions and applying budgets and actually building your capacity and capability to mitigate the controls. And it's not a one and done. This is not like, oh, we're finished, we did our assessment, okay, we can go back. It's an ongoing, constant process, because even if you're in a nice structured OT environment that never changes for 15 years, the threat landscape is always changing. Your your risk appetite is actually always changing. What's happening in the macroeconomic world changes regularly. And so reassessing and reevaluating, are your controls sufficient? What's next on the prioritization list to be addressed? And verifying that your mitigating controls are in fact doing what they said they do are all part of the ongoing process of securing your infrastructure, whether that's IT or OT.
I want to reemphasize what you said there. Even if your OT environment is static, the threat environment changes, and your business motivators can be changing too. So you have to constantly evaluate. And another thing I like that you said too, let's say that I have a certain version of Linux that has a security vulnerability across OT and IT. Doesn't mean I'm patching everything. On the OT side, it may be I can't patch that because name the critical infrastructure. So I have to come up with a different remediation for that device, aka locking it down completely as far as network, and monitor the firewall around that one device more rigidly. That might be a different remediation than doing the patch, for example.
So Darren, two things we've seen successful inside OT environments. And these two terms I'm going to use of that new kind of mitigating control when you can't patch or just flip a switch and turn on encryption. One is what I call a watchdog approach, where you take a modern system, put it right up next to a legacy system on the wire, so that it can monitor and have the advanced inspection and detection and
They're
protection
watching everything.
capabilities
Yeah.
on behalf of the device that it's proxying. And the other approach that's often used is what I call the canary approach, where if you've got an environment where you have a segmented network of legacy systems that are hard to patch, you can't get the tight security controls, you put a detector in there on the network that has those advanced detection, and it becomes the canary for that segment. So it will alert, whereas the legacy systems don't have the capacity to alert or to tell you that something is being attacked or being targeted. And so that watchdog and canary combination is a different kind of compensating control that is very popular in OT because it doesn't require going and changing the PLC itself. It's about adding the right IT capabilities into that environment to proxy those systems and to give them the capabilities without impacting the mission critical functions.
Anna, there's also another thing I heard. I was talking to our own OT organization, and they were saying we actually can't patch some of the devices in our infrastructure because we're not allowed to, because the vendor, right? It's their machine, right? If we touch it, then our warranty on this multi-million-dollar particle accelerator or whatever it is, right? It is now null and void, right? We can't enforce some of our security things on some of these embedded devices, but we know that there's a vulnerability in there, right? Yeah. Is that a common thing that you're seeing as well, or is that just unique to these really huge, manufacturing or fab OT systems?
So I think it can definitely be the case. Like a lot of on the industrial side, what we really worry about are the control systems, because that's where you can go in and mess with things, right? Otherwise, you have to be.
That's where you're messing with the physical world, right?
Exactly.
Yeah.
I'm sorry, I just got a cough. So, so updating those control systems, you're not going to be doing that in isolation. You're going to be doing that in close coordination with who the vendors are, and make sure that you've got a plan that you've executed with them. The other thing I wanted to mention, because we haven't talked about it yet, is often in the OT systems, your only window for really doing updates is when you're shutting down for plan maintenance. So that's another factor that comes into it, is you really do have to say, well, when I worked in refining, we did turnarounds between 3 and 5 years, depending on the type of unit. Literally all of the updates to major systems had to fall within the 3-week period of a turnaround, because that was the only time it was really safe to go in and change those systems. And it was also the only time we could actually test them to say, hey, we've just made this change. Is it really ready to come back online? And so those intervals around the planned maintenance can also be extremely important, as well as the point that you brought up, Darren, which is, man, talk to your vendor, right, when they're part of those critical systems, because they will have strong opinions, right?
I'm sure they will.
About how to do that properly.
Now, in a refinery where you worked, how often are these turnarounds? How often do you get to do that? Once a year? 6 months, 3 years, 4 years?
Yeah, typically the kind of average cadence was about 4 years. If you were really stretched on profitability, you try and push it to 5, just because those are extraordinarily expensive. But yeah, so about a 4-year time frame, right? So if you can imagine, you've got a control system that's running everything, and you only get to touch it once every 4 years, right?
That's crazy.
When you touch it, now you've got a window that's maybe, if you're lucky, it's 3 weeks, and if it's something you can do the maintenance on really quickly, it's like 1 week, right? So fit in everything you got to change in a 1 week period, and you got to plan for that, because you know your next opportunity for an update is also going to be
4 years.
And we see a similar cadence in a lot of military systems as well, with the tech refreshes being once every 3 or more years, One of the techniques that we're seeing being adopted by a lot of the more advanced organizations, and we're seeing vendors actually supply this to their customers of some of these OT environments, is what's called a digital twin. And the idea is that you have a
Mhm.
digital virtual version of that physical asset, of that PLC or that controller, that you can apply changes to, you can do patches to, and run simulations and basically run it through its paces to see what impact it may have on the digital twin version. Now, it's not, you're still going to want to do physical real world testing, but it allows you to do a whole lot of pre-loaded tests before you ever get to touching that system, where you got that 1 week window to do all of your testing and all of your patching. And so we're seeing digital twins come up. I've seen them in the construction industry. I've seen, in HVACs, where there's digital twin versions of those
Mhm.
that are supplied along with the product for the contractor to basically run their simulations, both from a patching, but also test on load, be able to look at the environmental conditions and changes there, and be able to do those tests in a virtual simulated environment. And that's one technique that can absolutely be applied to security patches as well.
We're also seeing, I've been approached by a couple of state governments to set up an OT cyber range, um, where and their primary focus has been on the electrical grid system, which I found totally fascinating. Right, they want us to help them establish an OT cyber range so they can test out some of these new architectures that we're talking about, like the Watchdog, the Canary, the data diode, and some new ones that we're talking about around. One is called the patch or the patch airlock pattern, which is an interesting pattern as well. Do you, even with these things, we still have this long cycle time between being able to update. Anna, do you ever see us where we could do continuous updates on these critical infrastructure systems, or is there just too much risk involved in updating, controllers as they're operating?
Yeah, and I think yes, with time, and a lot of it's redundancy of capabilities,
Okay.
right? There's been work going on for, it might even be 7 years now. That is the Open Process Automation Forum, and they have been leading a consortium effort through the Open Group to really do a modernization of control systems for not just refining, but chemicals and pharmaceuticals and kind of all the groups that use those sophisticated control systems. And they're specifically addressing this, right? They've got a whole cybersecurity subcommittee, but much of it is really coming down to what's the design, how do you have the redundancy set up so that if you lose one capability, do you have failover within the time frame that's important so that it doesn't kick out your equipment? Because a lot of equipment, if it loses a signal, like through a power failure, even a power blink, that'll just take it down. So there's some real hard and fast rules there. I think all of that is fantastic, but I'll kind of add on top of that, the next thing that has to happen is people have to trust those systems. And so once they've got a good design and they start doing those in test beds, there's going to be a lot of rigorous testing that goes on for probably years. And then deployments will be in very low risk systems where if you do have something go down,
No one's going to get hurt,
nobody's
right?
going to get hurt, right? So
Yeah.
probably start out with wastewater because wastewater is pretty, it's you don't,
It's
you know,
smelly. That's about it.
well, and you can kill your bugs, but then it's easy to recover from, or at least
Yeah.
it's recoverable in ways that other technologies aren't. So yes, I think we will get there, but it is a slow process.
We can't put too much reliance on patching as the only compensating control. I know that the security
Agreed.
industry spends a lot of
Yeah.
time saying,
There you
"Oh,
go.
just patch your system, patch it," and security hygiene is important. I absolutely. But as Anna is indicating, you can't rely on that as your only major compensating control. And that's why when we look at an OT system security, it's got to be an overall evaluation from the security aspect, not just can I patch the operating system, the firmware, or the
Well, that's
application.
the number one tool that IT uses, right, for security. It is,
Absolutely not.
Steve.
There's one of many categories, and that's really the goal here: is finding out the right security control, the right security tool to mitigate the risk. And it's not always going to be. And in the case of what Anna was talking about, it often can't be
It
patched unless
can't
you have
be.
four
Yeah.
years. And That's 4 areas of risk that you should not be, sort of accepting within your organization. So that's where, segmentation, encryption, strong authentication, inspection, detection, prevention, all these kind of things come into play, providing the surrounding controls to compensate for the one that you can't use, which is in
That you
this
can't
case
use.
patching.
Gotcha. No, I like that. Another thing in the OT space I know is very different. In IT, if we have an asset that has been compromised, we typically isolate it. After we've done some forensics on it, we isolate it, right? Then we restart it, we clean it, and restart it. That's a typical pattern. I can't do that in the OT space, right?
Yeah,
I
not
can,
easily, not without a great deal of expense and with taking other things down with it,
right?
right? Unless you're super lucky.
Yeah. So, what approach can I use in the OT space if I know that I have a device that's been compromised? What do I do? If I can't take it down because maybe I am a PLC controller in a refinery, and we know once you shut a refinery down, it takes a long time to bring it back up, right? So what do I do? What techniques do I have at my disposal?
Yeah, and I'm trying to think through that, and I have to say that is a really good question and one I've never asked myself, and so I'm hoping Steve has an answer
I'm
to
up
buy me
all
some
night
time
worrying about stuff
time
like
to
this,
think about
Anna.
this, because that's a super tough one. Because besides higher monitoring, and then trying to add something else into the chain that allows you to see, to see if that is really being exploited or if it's, what the real status is. I have no good answers for you.
So let's make a distinction between something you find to be absolutely vulnerable to an exploit and something that has been exploited.
Okay, that's
So
fair.
Yeah.
if
Let's
it's vulnerable
differentiate
to
the
an
two.
exploit, so you've got a known vulnerability that's active exploitation in the field, there are controls you can put in place to isolate, segment, and
Right.
inspect the traffic to and from a device to monitor it for aberrant behavior. There are things you can do today, and you can do that in the IT world, you can do that in the OT world. Oftentimes you have to do that when you have a known vulnerability that doesn't have a patch, but it's active exploitation in the case of a 0-day. You don't have a patch, but you can turn the dial to 11 on the infrastructure of security
Like
surrounding that.
Log4j is a great example, right?
Exactly. In the event that you have a OT system that has been compromised, so you've detected the aberrant behavior, you've detected the signature of a OT style attack, or you've noticed the firmware has been swapped out. That's where, again, in one of the good parts of OT systems that they're highly redundant in often places. So that's where you're going to kick in your process and procedures that you have for if it was a non-cyber event, if it was a physical.
If it is a physical event, gotcha.
So it's the same way as if a power station goes down because of a weather storm, you have redundancy built the system to help handle the load. If you're under active exploit, you have been attacked. You've identified a power generator or a transformer that has been compromised. Kick in the process you already have for dealing with every other kinds of outage, and take that thing offline before it can infect the net. And we've seen where cascading events can happen where you get one OT system infected because you don't have often the inspection tools. The lateral movement can be a lot faster to the systems that it's connected to, because again, there isn't the same level of controls once it's into the, it's the old adage of the egg. You've got a hardest shell, but once you get in, it's nice and soft. OT systems are often the same way. Once you get past the door and one of those key mission critical
The air gap,
systems is compromised, you may have to take a lot of it offline. But again, that's where you kick in the existing processes. And one advice that we give to CISOs and organizations is game the system. Before you ever get a vulnerability or an exploit that you have to deal with, run the wargaming on your environment. Actually, identify a PLC and have it be quote unquote taken out, and run the course and see what would be the problem. Make sure you've covered all your bases and you know what the procedures, and people all the way at the tactical edge and at the executive level all know their role in the event
in
of
doing
that
it.
happening, will make, when it does, that much smoother.
So what you're telling me is run my OT business continuity scenarios. That's
Absolutely.
which makes sense,
and
which means I have to have them.
There's a really good context for doing that. Every manufacturing facility, at least in the US, is required to do what they call HazOps. And it's exactly what Steve described. They don't tend to focus on cyber threats, although I'm sure that is definitely evolving and that is happening now. It tends to be more, hey, this pump fails, or we've had a power failure,
or a hurricane or a tornado hits somewhere.
But it's very easy to take that methodology and say, now let's apply that to, hey, our system has been hacked, and it's been hacked in these particular ways. Now, what does that really mean, and what is going to be our response, and how can we design in mitigations, right? And how can we change our system so if it does happen, there's much less vulnerability, right? Or it's back to can we live with that? Because some things you can live with, right?
Right. Guys,
yeah,
this has been very insightful as always. I love talking to you guys. Any last words for our listeners today that are dealing with this OT and IT side of things? What would your advice be to them that are dealing with, this convergence that we're already starting to see? We'll go with you first, Steve.
Okay. So I think, just restating what we said earlier is that it is already happening. It's not, well, I'll wait and see when this happens. Your IT and OT systems are blurring. And so it's take the measured approach of understanding your assets, providing, doing the risk assessment so that you can apply proper controls and security to the systems you have, and start planning for it. And then the key is get out of analysis phase and get into implementation. So knowing that this is going to be ongoing. If you spend all your time analyzing your environment and none of your time actually implementing the controls, you're never going to get anywhere. It's a feedback loop. So you analyze and you go deploy, feedback into the analysis, and continue. So it's going to constant process. It's a continuous security assessment.
So it's not a one and done.
It's not a one and done. And the key thing is to start deploying the security now, and getting that visibility into your environment is the first step in being able to understand what's going on and what your risk posture is, and what your risk, and be able to then manage that risk across your OT enterprise.
Sounds good. Anna.
Yeah, and I would say on the OT side, you as an operational company, start bringing in your IT folks and treating them like they're part of your operations, and make sure that they understand the implications, make sure they are equally involved in all of these discussions, because there is no longer a reasonable path that treats them in isolation and just has them worried about your PCs. They need to be integrally involved in what's happening, and they need to help bridge the gap between what we understand of the operational systems and all the electronics and all of the compute that's necessary to back that up.
Thanks, Anna. I think that's absolutely critical. I'd say on the CISO side as well, bring the OT guys to sit at the table, at the top of the table with you. Because I've seen this before where a CISO mandates down to the OT guys, you will do this. And they're like, no, we're not. Right. But if you're sitting at the table with them at the front of the table, then they have a say. Then you can talk about the differences and really take a look at the paper. It is on the website. We talk about the differences between OT and IT and how we're going to get over this division. So, all right. Thanks again, guys, for coming on the show.
Thank you, Darren.
Thank you, Darren.
Pleasure as always.
And thank you, Anna, for your insights.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.